Hi, this is Ezra. Today we are going to solve the June cook-off per capita income problem. So, let's get started with the problem description. There are n provinces numbered through 1 to n and m bidirectional road connecting them. Now you can imagine a graph having n nodes and m bidirectional paths. Okay, there are two arrays A and B of size n. For each valid I, A of I represent income and B of I represent population. That means each node has a population and a income. Okay, so the per capita income can be defined as A of I divided by B of I, which is nothing but income divided by population. Okay, and now we are asked to choose one or multiple provinces in a way that per capita income of the kingdom collectively will be maximum possible, and it must possible to travel from each of the chosen province to any other chosen province without visiting any of the abundant provinces. Let's look at this example. Consider 1 and 3 collectively satisfy the first condition, that is, giving the maximum per capita income of the kingdom. But if we want to travel from 1 to 3, we must travel through 2, and it is the only way. But the second condition tells that we cannot travel through the abundant provinces. Means this example won't be valid. But if we consider 1 and 2, okay, now we are able to travel from 1 to 2 or 2 to 1. Now this will also satisfy the second condition. So the answer will be 1 and 2. But what if we have multiple solutions with the same max per capita income? Okay, then we will have to choose the solution with higher number of provinces. It may sound a little weird, but as we continue, everything will be clear. Now let's move to the first example test case. This problem can be graphically shown as here, where A and 2 are connected, 2 and 3 are connected, and 1 and 3 are connected. The per capita income of each province can be calculated as here. Province 1 has PCA of 2, Province 2 has PCA of 1, and Province 3 has PCA of 2. The possible solution to this example can be seen here. If we consider only one province, then Province 1 and 3 has 2 PCI, so they are maximum among them. And if we consider any two of provinces, then the Province 3 and 1 giving PCA of 2 is the highest among these three. And if we consider all the provinces, then the PCA of the kingdom will be 1.857, which is smaller than 2. So the solutions can be either 1 or 3 or 3 and 1. Now we should consider the second condition too. Means we should print the answer or the solution with higher number of provinces. Here if we choose 1 or 3, then the number of provinces will be 1. But if we consider province 3 and 1, the number of provinces will be 2. So we will print this solution, the province 3 and 1. And now we also have to consider the third condition as well. The third condition tells us that we should able to move from the chosen provinces to any other chosen provinces, which here we can move through 1 and 3 because 1 and 3 are connected. So the answer is valid. The answer with 1 and 3 is valid. As we solve this example, considering all the possible solution, a question comes that do we really need to consider all the possible solution? Because if we consider all the possible solution, then the time complexity will be very high. So there are some facts before moving to the next example. Let's look at these facts first. The first one is, if we add a province with lower per capita income to a province with relatively higher per capita income, then the collective per capita income will always be less than the higher per capita income. So, what's this? If we consider province 1 has income x1 and population y1, and province 2 has income x2 and population y2, and if province 1 has a higher PCI than the province 2, then that means x1 by y1, which is income divided by population, is greater than the PCI of province 2, which is x2 by y2. Then I did nothing. I just grabbed the y2 from here, uh, from RHS, and multiply into the LHS, and grab the y1 from the LHS and multiplied it with its value corresponding to the RHS. And after the second line, I add x1 and y1 in both LHS as well as RHS. Now you can see x1 and y1 here, and x1 y1 here also. Then I carried out x1 as common from these two statements, these two multiplications, and if we carried out x1, then there will be y1 plus y2 from the both just expression, and in the RHS I carried out y1 as well, and it will left with x1 and y1. Then I brings back this y1 into the LHS, and I grab the y1 or y2, and I divided this value with RHS. Now we can see x1 by y1 is greater than x1 plus x2 divided by y1 plus y2, means the higher PCI, and this one is the higher x1 y1 is higher than the collective PCI, which is x1 plus x2 divided by y1 and y2. So we will never add a higher PCI, sorry, a lower PCI with a higher PCI, means we will only consider the higher PCI. But what if we have multiple provinces which has the PCI as same as maximum PCI? Here comes the second fact. If we add two provinces with the same PCI, then the collective PCI won't change. Let's look at this example. Province 1 has income 10 and population 5. Province 2 has income 2 and population 1. The individual PCI is 10 divided by 5, which is 2, and province 2 has a PCI of 2 divided by 1, which is also 2. And if we consider the collective PCI, the this will also have a value of 2, because 10 plus 2 divided by 5 plus 1 is also 2. Now we are all set to move on to the next example. In the next example, we have n provinces and m roads, which means we have 8 road connecting those 9 provinces. Here we can see in this graph, and the income is given in array A. The population are given in array B as well. If we want to calculate PCI of individual provinces, we can see the province 1 has 1.25 PCI, 2 has 1, 3 has 1.25, and 4 has 1.25 as well, 5 has 0.5, and 6, 7, 8, 9 has a PCI of 1.25. Now let's consider the first fact. The first fact tells us that we should only consider the provinces which has the higher PCI, means same as PCI same as maximum PCI. So here maximum PCI is 1.25. So we can only consider provinces 1, 3, 4, 6, 7 and 8, 9. Now if we consider the factor means um, we can we can select those provinces which has the PCI same as max PCI. Here 1, 3, 4, 6, 7 and 8, 9 has CPI same as max CPI, which is nothing but 1.25. So we can only have solution in between these 7. We cannot consider 2 and 5 in the solution. But can we select all those 7 at once? The answer is no. Here is why. Because these we can see these 3 clusters, the green, red and blue. If we want to travel from blue cluster to red cluster, we have to travel through 2, and if we want to travel from green cluster to red cluster, we have to travel through 5. But it will violate the problem description because 2 and 5 are not chosen, so we cannot pass through them. So the answer is one of these 3 clusters. But I can remember the problem description says that we should only consider the answer which has a higher number of provinces. Here the cluster blue has 2 provinces and cluster red has 2 provinces, but the green cluster has 3 provinces. So the answer can be this green cluster. So the final answer is 6, 7 and 8. That seems easy, right? But how can you find out those cluster? Because only after that we will be able to select the cluster with high number of provinces. I hope you remember BFS, because if we do a BFS search on 6, we can find out 7 and 8 as well. And the total number of provinces this BFS will give 3. And here the BFS on 1 will give the number of provinces as 2 and the values at 1 and 9. And the BFS on 3 will give number of provinces as 2 and values at 3 and 4. But how can we code? Before moving to our ID, let's look at the input format, output formats and constraints. Here the input format will be the first line will contain T, the number of test cases, then second line will contain N and M, third line is array of size N, then fourth line is array of numbers of size N as well, and M lines, each line will contain 2 space integer U and B, which will give the pass of road. These are the constraints. T will be between 1 and 5, M N values will be between 1 to 10 to 10 to 5, U and B will be between 1 or N. Here the input is consider 1th indexed, but we are gonna use 0th index, okay? And there is at most 1 road between each pair of provinces, and A and B, each of A and B lies between 0 to 10 to the 9. The output would be the first line will give output K, where K is the number of chosen provinces. K is nothing but the number of provinces in the cluster and index of each chosen provinces. Here index of each chosen provinces is 6, 7 and 8. So for this question we'll have to so the output as the first line of output will contain 3 and the second line of the output will contain 6, 7 and 8. In order to solve this problem, we need to perform 3 tasks. The first task is to choose provinces with maximum per capita income. The second task is to do a BFS search on each chosen provinces in order to get each cluster. Here we can see if we choose 1, 9, 3, 4, 6, 7, and 8, because these are the valid provinces which has PCI same as the maximum PCI. So we will consider these 7, 1, 3, 4, 6, 7, 8, and 9, and do a BFS search on each of these provinces. First we'll do a BFS on 1, then 3, then 4, then 6, 7, 8, and then 9. Okay. Then in order to get each cluster, because here 3 and 4 will give the same cluster, and 1 and 9 will give the same cluster, and 6, 7, 8 will give the same cluster. After that, we have to select the cluster with higher number provinces. These are the three tasks we need to perform. So let's get the first task done. To complete the first task, we need to perform two subtasks. The first subtask is to find out the value of maximum PCI. First we need to calculate the individual PCI. Here we calculate the individual PCI, and after that we can we can be able to know the value of maximum PCI. After knowing the value of max PCI, we will select the provinces which has the PCI same as max PCI. Here 1, 3, 4, 1, 3, 4 and 6, 7, 8, 9 has the PCI same as max PCI, so we will select these 7. For better understanding, let's get to our IDE. Now I am in VS Code IDE. In the main function, I first accepted the value of t. Then I created a loop which will stop at t equals to 0. And in each iteration, the solve function gets called. This solve function is where we actually solve this problem. In the solve function, first I am getting the values of n, m, and the arrays a and b. After getting these values, first we need to perform the first subtask of task 1. So here we need to compare per capita income of each provinces with one another. Then we can get the maximum value. As the per capita income is income divided by population, so this is a float. But as we know, there is a precision limit in floating point values in programming. We coders actually try to avoid floating values as much as possible. And remember, never use float values as a key in hash map or as a mean of comparison. So we really don't want to mess up our code because of precision, right? We'll try to ignore float. But how? Here is why I use pair of long named max pair, and I stored the value for the value of PCI of first province. I stored the value of numerator and denominator separately in this max pair. Then I declared a pair named temp pair, which we will use to store the PCI of ith province. To get the max PCI, we need to loop through each of the provinces and compare their PCI with the max pair PCI. Okay. Here what I did, I created a loop of a for loop, and then in each iteration, first I stored the PCI value in temp pair. Then I compare temp pair with max pair. Here I used a function named comp for comparison, and this comp function returns true or false. If temp pair is greater than max pair, it will return true, and if temp pair is less than max pair, it will return false. So if it return true, then temp pair is maximum than max pair. So we will store the value of temp pair into max pair. Here you can see the definition of comp function. This function only return true when the first pair is greater than or equals to the second pair. After getting the value of maximum PCI, now we need to perform the second subtask. In the second subtask, we need to find out those provinces which has PCI same as max PCI. So here I declared a vector name valid, which we will use to store the valid provinces, and then a vector name visited. We will see its uses later on. Okay, after that, I uh, again loop through each of these provinces, and I check their PCI with the max pair PCI. If this return true, means the temp pair is equal to max pair, because temp pair can never be greater than max pair. So the only possibility would be the temp pair equals to max pair, because in the comp it will also return true when the first pair is equal to the second pair. So here we can see it will return true when temp pair is equal to max pair. Then after that, we need to store the value of I, means the index of the province in the valid vector, and we mark the mark the province in the visited vector as false. Here we complete our first task. Now let's move on to the second task. The second task is telling us to do a BFS search. Sorry, this would be search on the chosen provinces in order to get each cluster. First, we need to get the inputs of M paths connecting pair of provinces. Here I used adjacent list representation of graph. After getting the inputs of U and V, we first need to decrement this, because the inputs will be in one index format, because but we are using 0th index in our code. So first we will decrement this. After that, we need to check whether U and V are marked as false in the visited vector, because in this for loop, while we are pushing back I, we are also marking visited of I as false. As we are initialized the vector visited vector with value true, the rest except those valid provinces should be marked as true. If both are marked as false, then the if condition gets true, and we will push back U in the graph of V and V in the graph of U, because we only want to consider those paths which are connecting two valid provinces. We should not consider the paths having unchosen province, because we cannot even pass through them. After getting the inputs and creating the adjacent list representation of this graph, we now need to perform BFS on each of the chosen provinces. So we have to loop through the valid vector in order to do that. In each iteration, we first need to check whether the province is already visited, because the provinces in a cluster will give the same VFS. So we need to perform only one VFS on either of the provinces. This if condition will help us to achieve that. If the province is not visited yet, means this if condition gets true, then we will perform VFS on that node. Here we will use a temporary variable named max node to count the number of nodes get pushed during the VFS. Here you can see the max node gets incremented as we push another node into the queue, and also we mark visited of j as true in order to avoid the repetition of VFS. Before this for loop, we have declared two variables named maxi and max. We will use this max to store the value of maximum possible number of provinces we can get from those clusters, and in this maxi we will store that province which gives us the max value. Here, after this while loop, means after this BFS, we will check the max node with max. If the max node is greater than max, then we will store the value of max node into max and change the maxi value into I, because this I is giving us this max node, means BFS on I will give this value of max node. After performing VFS on each cluster or each of the valid provinces, we will now have the value of maximum possible cluster size and the index of that province giving the cluster. First, we'll have to print the first line of output, which is nothing but the value of max. And after that, we only need to perform another VFS on that maxi province in order to get the provinces present in that cluster. Here is the output of the second line. Yeah, that's it. We solved this problem. See you in the next video. Thanks for watching.